So today I want to go over how to triage crash reports and how we can make them useful and make some sense out of them and actually track down and root cause the thing that caused the crash to happen. So here we are in Ubuntu 22.04. This is the latest version of Ubuntu that released, the latest LTS version. And it is in VMware, and I noticed the other day that this crash report came up when I was trying to move files. Now it says here at the top the executable path of the program that had an error was user bin Nautilus, and Nautilus is part of the file manager for the GNOME system, the GNOME desktop environment that Ubuntu ships with by default. So if we scroll down through here, we see that, all right, well, it was Nautilus. The problem type was a crash. Okay, that's good to know. Title of the crash was that Nautilus crashed with a SIG-SEG-V in G blah 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 validate. This SIG-SEG-V right here means that it had a seg fault, and what that means is that the program tried to access something, memory, that it was either invalid or not accessible due to permissions. Okay, so we have some sort of memory dereference or access that was not able to happen, so the program threw a seg fault, and that's why it crashed. Okay, so we can keep scrolling down, scroll down. This part right here, the disassembly, that's always handy to look at. So here we see that the line it actually crashed at was in this GUTF-8 validate plus 16 bytes. So the disassembly for that line is this move of a dereferenced RDI. That's these two parentheses here, is we're dereferencing whatever's in RDI and we're moving it into EAX. Okay, so there was something in RDI, we derefed it, moved it into EAX. We don't know what was in RDI, but whatever was there was not good. Okay, so keep that in mind. So we can keep scrolling down, scroll down some more. This proc maps is really important, especially for triaging crash reports post-mortem, meaning the program is no longer running. All we have is the crash report. And we can see here at what addresses programs were loaded at. And that's going to be very important later on. For this report, in this window that we're looking at, it is truncated, so it doesn't show you everything. See down here at the bottom, there's 3 dots. So not everything there is listed, but we can go to the actual crash file and grep through it and find things that we need. But for the first image that was loaded, the Nautilus, that makes sense because that was the executable that had the seg fault. And that was loaded at this first address here of blah, 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 41000. And that's the base address for the Nautilus. And that'll be handy later. Okay. Some of this is actually super useful to write down. So, we know that the executable we're interested in is user bin Nautilus. And we know that the load adder for that was 563C9ED41123 for 3 zeros. Okay, that's awesome. Some other pieces of information. We knew that there was a SIG-SEG-V, and that was, if we remember back to the assembly, that was moving something that was dereferenced from RDI into EAX, and that is AT&T syntax. So if we look at that into Intel syntax, excuse me, it was something along the lines of that. So same. Okay, all right. So if we kind of go down a little more, you can see here registers. So according to our notes and what we remembered earlier, there was something in RDI that wasn't good. And if we look here, it says RDI is 0. So we tried to dereference 0, meaning we tried to look at what was at the address of 0 and get the value there. And the address of 0 is invalid. Therefore, what we tried to do is dereference 0, or this is also known as a null dereference. Okay, so whatever code led up to the point of RDI having 0 in it, something bad happened. So we gotta track that down and root cause it. Okay, here there's a super handy section. It says segv analysis. So for the sig-segv that we had, it attempts to kind of culminate some information together and tell us a little bit more about it. So a seg fault happened specifically right here at this address. That's super handy. So the seg fault happened at 7F36ED243B40 in a function called GUTF-8 validate plus 16. Okay. All right, and then the PC or RIP, the same thing. That's where we crashed at in that validate. And then the source was RDI, and it's saying that the zeros was in RDI, and that's something that we've already figured out. And we also saw from our disassembly earlier that it was trying to move into EAX. Okay. All right, so that's pretty much everything we've already found. Okay, so if we keep going down, another important part is stack trace. So stack trace is going to show us things that led up to where we crashed. So we crashed at here, this B40, which we already notated. That's where we crashed at. But what we didn't have before, we did not know that this GUTF-8 validate was in this library. So we're going to go ahead and notate that down. So that is in lib x86 64 Linux new .z. Okay. All right. So we know that the main program was Nautilus, and we see here that the thing where we actually crashed at was in a shared library. So Nautilus launched, loaded a library, and at some point called this validate function inside of it. And that is where the bad things happened. The call that happened directly before this, before we ended up in the validate function, is here in this 563 blah 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 FB0. But you'll notice out to it there are question marks, and there's no library or executable or anything listed. Okay, so the thing that happened directly before we loaded the library or called that function was located at 563C9ED9EFB0. We don't know what that is. Now, if the program was still running, we could attach to it with GDB, but this is post-mortem. This has already crashed. So, if you remember before, I mentioned there was a proc maps in the crash, in the actual text file or crash file. So what we can do is we can go to, okay, this is our crash file. So what we're going to do is we're going to cat that out. And all that means is just display all the text that's in that file to the terminal, which there's a lot. So we don't need all that, right? But what we do want is we want to know what executable was loaded around this address. Now, this is a very specific address. This is what was where the instructions were called directly before this validate. So if we put that in there and search the file for it, pretty much all we're going to find is stack traces. So stack trace indicated by this pound sign here. So So we need to make that more generic. Maybe get rid of a couple hex characters in it. Same thing. Get rid of a couple more. Ooh, that's a little better. Okay. Yeah. So that address that executed right before we went into the validate is actually in range of this executable, which is Nautilus. That's our main executable. Okay. Why that didn't show up in the stack trace? Things happen when programs crash. It's not always accurate. But with this dumping of the proc maps, it says, hey, these are all the programs that were loaded in memory. Here's their addresses and kind of what ranges they took up. So we can see that that address that we're interested in was located in Nautilus. And the load address for Nautilus is here. And look at that. We already have it from our previous analysis of the crash window up here. So what else do we need? Well, we have the load address for Nautilus. So let's get the load address for our library. So we can do the same thing. Cat the crash file and grep through it, except this time we're going to look for any instances that list this library. Okay, it's quite a few. And if you remember, the pound sign here means, it's part of a stack trace or something. So we can move that out. Here's our command that we just did. So right after it, that looks like a load address to me. And that is our library. So our library was loaded at this address. Boom. So we know that Nautilus was loaded here. The last address of where instructions were called from it are here, which led to us going into this validate function, which is in the libglib library, which was loaded in memory. The base was loaded here. Okay? All right. So that is pretty much all the info we need from this. There are a couple more things, but that's pretty much all we're going to look at for now there. Okay? So what we're going to do now is we are going to fire up Ghidra. If you're not sure what Ghidra is a disassembler, much like IDA Pro or Redair, Binary Ninja, things like that. It's completely free. All you need to do is Google Ghidra, and you can put it on your machine completely free. All you need is Java, and it'll allow you to disassemble files. So the two files that we are interested in is user bin Nautilus. So what we're going to do is we're going to make a copy of that. We're going to copy. Copy user bin Nautilus. I'm going to copy it to downloads. I'm just going to put a copy of it in there. The next one we're going to copy is this library. And the reason we're doing that, I'll show you shortly. So we got our two files, our executable and our library. Now in Ghidra, what we're going to do is create a new project. So non-shared. And name it Nautilus. And finish. Then we are going to import a file. We put it in downloads. We're going to import Nautilus. Okay. Now this is important. There's an options button here. This is going to make your life immensely easier instead of trying to do this later on in Ghidra. It's a little rough. But if you do it initially, it's very easy. So we're going to go to options. We're going to go load external libraries. And then every single one of the top one, the dot, you're going to leave that. But for all the other ones, you're going to highlight bin, and then just start hitting the X. Get rid of all of them. Every single one of them, except the dot. Leave the dot. The dot says look for libraries in my current directory where Nautilus is. And if we remember, we put the libglib in the same directory as Nautilus. So it's going to find it. Now where we want to load Nautilus at, the base address we found earlier from our research, we're just going to paste that in. That's where we want Nautilus to be loaded. We hit OK. And what this is doing is going through the initial file, is parsing it out, it's looking for any of the libraries that it was able to find. And we see here that, oh, it found our libglib and went ahead and imported that for us. Now the file we want to start with is Nautilus. So we're going to double click Nautilus. Nautilus has not been analyzed. Would you like to analyze it now? Yes. And just leave it default. Hit analyze. You'll see down in the bottom right our status for the analysis. It takes a little bit. But what that does is goes through the file, disassembles it, finds assembly instructions, functions, definitions, cross-references, strings, a whole bunch of things. So it's examining flow and doing a whole bunch of analysis on this thing, trying to get it ready for you to go ahead and find what you need to find, okay? And because we modified the base address, we see here that it is starting the base address of the binary here at 41000, which is great. So if we go back to our analysis, we see that the last address called from Nautilus was here, this EFB0. So we're going to copy that, and we are going to go there. Bam. All right. Now keep in mind, addresses on the stack for a stack trace or a backtrace are the next address that you're going to return to after you return from whatever was being called. So if this is the address we were going to return to, that means the previous call was right here, just one line up. And we see there, yep, sure enough, that called UTF-8 validate, and it is in libglib. Okay, awesome. Now Ghidra does a special thing and not only disassembles the code for you, but it decompiles the code back to sudo C, which is pretty handy. Oops, just lost my place. Okay, so here we click on UTF-8 validate. We see it's here on line 31. So we see the line directly before it is G file get base name and then some parameter passed to that. And that's assigned to PB-var7. PB-var7 is passed into GUTF-8 validate as the first argument. Right there. That's interesting. Okay. So what does GUTF-8 validate do? We don't know. Let's go look at it. So if you double click it, it will take you to the export for it. And what you need to do is go ahead and click on it again. What it'll do, that will open up the libglib that it imported earlier. Now it asks if you want to analyze it. We don't want to analyze it yet, because if you notice, the addresses are in the range like 563. That's not right, because according to what we found earlier, it's loaded at 7F36 blah blah blah. So what we need to do is click on this little RAM memory icon looking thing. And then over on the right hand side at the top is a little house. If you click on the house, that allows you to rebase the image. So we're going to go over here. We're going to paste our load address and hit OK. Now everything has been moved to that base address. And what we can do is go to Analyze. Just leave everything default. Hit Analyze, and it'll go through everything. If we go back a little bit, go back to Nautilus while the libglib is analyzing, and we look at the pseudo source, we see that the function called directly before UTF-8 validate is g file get base name. So this is pretty distinct in that you have one call to a function, and then directly afterwards you have another one. And the great thing about Linux is just about everything is open source. And what we're looking at now is Nautilus. So we open up our web browser, type in Nautilus source. The first thing that pops up is GitHub and the GNOME project for Nautilus. Okay. If we go up to search and type in our function that we're interested in, so g_utf8 validate, and we search in this repository, not all of GitHub or the organization, but just in this repository of Nautilus, we see that we have 4 results. That's not a lot. That's pretty good. So it's good to narrow things down. And if we look back, you see that, again, this is pretty distinct because there's 2 calls directly after each other. So gfile get base name comes directly before the validate. Okay. Doesn't look like there's one here. Does look like there's one here. And that looks very similar to what we have. Gfile get base name, gutf8 validate. That looks very, very similar. So if we click on that in the line number, 1022, we can see the gfile get base name. It's passed in some file parameter of some sort and returns the result to this base name. The base name is given to UTF-8 validate as the first argument. The second argument is -1, and the third argument is null. So the only varying argument to this function is base name, and the thing that modifies base name is directly before it. That's this. So whatever this did, it returns something to base name, and that gets passed to UTF-8 validate. Okay? That's the same thing we see here. All these F's is just the 2's complement way of saying -1, and then null in the end, which we saw is just 0, and then pbvar7, that is the base name. Okay? So if we go into UTF-8 validate, looks like our code is done analyzing. We see here that param1, we're going to rename that with L. I'm going to say base name because that's what it was named passing in. And we see that it's some sort of byte pointer is what it thinks it is. And we see that the first reference or modification or anything done to base name is right here, line 14. And we see that we use a star to dereference base name and put it in pbvar1. Now clicking on this line, it syncs it with the disassembly over here. And if you notice, the address where that is at lines up with where our crash actually occurred. So this is our null dereference. So base name was passed in with a null or 0. And then here at this 3B40, it tried to dereference it. And that is clearly an error of trying to dereference 0. So that is where the seg fault happened. That's pretty cool, huh? You take a crash report, dig it, tear it apart, dig into the code, and actually find in the disassembly of the binaries where exactly this thing happened. And not only did we find where it happened, we found why it happened. Is that this function, for whatever reason, the file just, there was no base name, whatever that is, for this file. So it was returned 0. But what this code failed to do is validate that base name actually had a value in it, or that this call even succeeded. It just took it at face value and passed the value to UTF-8 validate. Now, is this a Nautilus problem? It could be a Nautilus problem, because they could put code here. For instance, just, if not base name, then, return, -1 or 0 or 1 or something indicating that, this, something bad happened. So Nautilus could do this. They could put it right before this and indicate that, hey, we weren't able to find a base name, therefore we can't do this, so we need to do something else or free it or something. So it could be a Nautilus issue, or it could also be a glib issue as well, because we went into UTF-8 validate and it blindly accepted base name and did not try and validate it for any kind of value in there. So it could be a Nautilus issue, could be a glib issue. If you look up glib source code, glib, I think this is it, maybe. No, glib, yeah. Okay, so UTF-8 validate. Let me see that there are 29 code results for that. So there's quite a few in there. But we would just need to find the definition. Like, 1663. Here it is. This is the definition for UTF-8 validate. And we see here, this is very, very similar to the code we had. Yeah, absolutely. So this is saying it's supposed to be a car pointer for a string, so that's our base name. And then this was the first if that we saw. So there's the if to a validate length. Yep, same thing. And then fast validate. Don't know what that is. So fast validate is defined on line 1509. And let's see. So it takes in a string, so str. So it's a car pointer, named string, str. And let's see, it assigns p, which is this gcar, which is a custom data type. So it assigns str to p, and then dereferences p. So that right there is where the dereference happens. So this fast validate was just inlined, which is why it looks a little weird. And you'll notice too that the decompilation of the disassembly to the pseudo source is saying there's like a while loop here and stuff. But you'll notice in the actual code for fast validate actually comes out to a for loop. So it's a little different, but it would work out the same. I'm sure if we worked out this while loop, you can write for loops as a while loop and vice versa, just with different syntax. So not always take the decompilation at face value, but we do see that, yep, right after the validate length that we skip over, we get the dereference. And same thing's happening here. It's just happening right there. That's where it's happening. So again, is this a Nautilus issue? Is this a glib issue? Yeah, could be both. And both of them could use some checks to make sure that, not blindly accepting return values from something that is not guaranteed to succeed. But yeah, so I'm going to go ahead and report this bug. Y'all can report it. You can try it out. It's not, too serious of a bug. It just crashes Nautilus. Nautilus relaunches, so it's nothing crazy. But yeah, so that is how we can go from crash reports in Linux get some key pieces of information, do a little bit of research, find the files and open them up in Ghidra, and actually find exactly where these things happen. So I hope that was informative for you. If you have any questions, hit us up at ringzerolabs.com, and have a good day.